Hi there. My name is Brian, and I'm a solutions engineer with SAP. And I want to give you a little bit of a glimpse into something that I've been working on these days. In the IT industry nowadays, there's a lot of talk about something called the Internet of Things. And one of the key concepts that IoT focuses around is this idea of data streaming. Data streaming represents a platform's capability to connect out into things such as machines and sensors and to be able to consume that information in real time so that analytics can be performed on live data so that the business stakeholders can make key decisions on live information. And what I wanted to do is give you an example of what that looks like using SAP's real-time data platform. And to do that, of course, we have to start off with a sensor. And so what I've gone ahead and done is I've actually built a sensor to connect to, and I have chosen to use the Arduino platform. I chose it because I really like the platform's extensibility and its capability to build pretty much anything. It's well known to be easy to use, easy to learn, and it enables engineers to create almost anything that we want. And in this instance, I've created a simple two sensor setup. The first one is a temperature monitor, which is this tiny little probe here, and the other one is a water sensor, and the probe actually extends out to this cable here. And what I've gone ahead and done is I've taken this and I can connect it to SAP's real-time data platform so we can stream the live temperature and water readings in and show you what that looks like in an example of real-time dashboards and analytics. So I'm going to plug this in. This is going to light up. Let me connect it to my Mac. Now, as this is a fairly simple sensor setup, the sketch that I've uploaded is also a fairly simple one. The main components is going to be reading the water sensor, reading the temperature sensor. If we scroll down, the end of it, we wait a second. So we're taking one reading every second, and of course we can tune this however frequently we want to, but for the purposes of this demonstration, I chose to do it every second. And what I'm going to be doing is I'm actually taking this and I'm connecting it out to a Python program that I've written here. It's also a fairly simple one that just takes those readings and then creates an output string and puts it onto a bus that we can now put into our data platform. Theoretically, we could be able to do all this translation right on the Arduino itself, on that sketch that we've shown, and connect this to SAP's data platform directly. But for processing and for debugging purposes, I chose to have a Python program as a middleman because it also lets me do things like generate data, it lets me do a lot of text manipulation, and since the storage on the Arduino board itself is very limited, I wanted to make sure that if there's going to be any more code going forward to offload that onto my computer as opposed to burning it on the Arduino itself. And what this Python program is doing, as you see here, it's actually connecting out to a socket which is exposed out from the SAP Advanced Streaming Processor software that I'm going to go into in a second, and it's feeding this information to ESP as it reads it in from the Arduino. So every second this is producing data. The Python program is going to be reading that data in, doing a little bit of formatting, and then when we go down here, we see that we're sending that to ESP through the socket. And on the ESP side, let me open up. We have a very simple streaming process here. Actually, let me go into the graphical diagram so it's a little bit easier to see what we're doing. Let me close that so I can change it and organize it. So here we have a socket that's going to be listening for data, which is what our Python program's connecting to. And this one's just doing simple formatting to change things like to convert it to a timestamp, do some data type conversions because right now it's just reading it in as a CSV. And of course, we want to ultimately output it to the SAP HANA database so that we can perform analytics on there. And I'm going to show you what this looks like when it's actually executing. So let me start off by deploying and running the streaming program. So this is actually deploying it onto a live SAP ESP instance. And here is a blank slate because there's no data being fed into it right now. And what I'm going to do is I'm going to execute that Python program. And it's initializing. In a second, you're going to start to see these readings come in. So on the output here at the terminal, you start to see that now we have the name of the stream, we have a timestamp, and that's what I'm using as the identifier. Of course, we have the current time down to the millisecond, and then now we have the actual information itself. And you see now it's starting to stream into here as well on the ESP side. Let me go here. All right, so you see the information is coming in. And we have a few different pieces of data. So we have the water sensor, and this is the raw voltage reading, what's being shown here. So if I put my finger on it, because my finger has some conductive properties, you're going to start to see that the numbers are changing. Of course, you see the temperature on the last column here. So if I start to put my finger on it, see now it's going to 74 degrees Fahrenheit. It's rising to 77, 78, and so on. What I've also gone ahead and done is, so I have a visual indicator as well. The more wet the sensor gets, we're going to start to see LEDs go up as well. So when it gets to the damp setting, it's going to flash the yellow light, and when it goes fully submerged, it's going to flash the red light as well. And you can see that that information change in real time as well on ESP2. So let me dry that off. And if I go into SAP HANA, I'm going to open up a SQL box. Select star from. If I hit execute, you start to see that this information is showing up in our database as well. So in essence, what we've gone ahead and done is we've created an external sensor. We are now streaming this data in real time through SAP Event Streaming Processor, and this is loading the SAP HANA database in real time as the readings are being fed in. Of course, we want to take this one step further, and we want to be able to, let me know I don't want to save those changes. And so we want to be able to visualize this information as well. So let me go back to my run test. Because while numbers are great, and it's cool to see this information come in, we want to be able to visualize this information so that people can get a sense of what the data looks like as it comes in. And this is where the SAP Analytics Suite comes in. And what I'm going to choose is the BusinessObjects Design Studio tool. And so this is, with the latest, with version 1.4 is when it was first introduced, but as of 1.4, we've started incorporating real-time sources into Design Studio so that now we can have the charts and the graphs react to things as streaming data comes in. So let me show you a quick example of that. I'm going to create a new application. Just call it Test Streaming. And it's going to load up a blank slate for me. Now, if we create a new data source, see a new option here. It says Streaming Data Source. And this is actually going to be able to connect to the real-time feed directly as it comes in. So what I'm going to do is I'm going to put in server name. And we don't have HTTPS enabled, so I'm going to turn that off. And let me log in. You see when it connects, now it starts to show me my different workspaces, the projects, and the different topics. So if I go back to ESP, I now start to see that this particular project is called Python Debug, and the stream that's being outputted is in a window called Compute 1. So I'm going to go back here, and I'm going to choose Python Debug, and I'm going to choose a Compute 1 window. And because we have the data being output every second, we're going to update this every second as well. What I'm going to do here is I'm going to create the default data selections, and so I'm going to choose the Fahrenheit temperature monitor, I'm going to choose the water sensor monitor, and I'm also going to bring in the water level text description that I brought in, and you're going to see why in a bit. And for the column dimension, we're going to choose timestamp because, of course, this is all going to be streaming in as the data comes in, and we're going to want to be able to divvy that up by time. And we're going to click this button that says Show Live Preview. And what this actually allows us to do is, as we design it, it's going to have the graphs in our design window here react to the data as the data comes in. So instead of looking at some static picture while you're doing the design time work, you can start to see the effects of this as the information comes in. So I'm going to enable that. Click that. And I'm going to bring in a chart. Now, like a lot of different objects and a lot of different sources, it's going to be fairly similar in that when we choose our data source, it's just going to be choosing our data streaming entry. So if I click that, you're going to immediately see the graphs react. And now you can start to see that as the information is coming in through the streaming platform, it starts to react here in real time. And what I'm going to do is I'm actually going to change the type of graph because this isn't very conducive to what we're looking for, right? And so if I go to additional chart types down here, we see a new option, and it says time-based line chart. And this is actually a new type of chart which has been introduced specifically for real-time streaming data sources. And so I'm going to choose, just to give you an example, I'm going to choose a Fahrenheit measure. And for our time dimension, I'm going to choose timestamp, and we're going to see this redraw when I hit OK. So let me expand this out. I'm going to bring this up, and to show you that it's working, if I put my finger on here and I start to raise the temperature of the sensor, you start to see on the graph, and it resizes automatically, but you start to see that, that the readings are going up as well. And if I let go and give it a second, it should drop back down correspondingly. And that's an example of a real-time data source. Let me give you another quick example. I'm going to do the same thing over here, and I'm going to choose the same data source. And down at additional chart types. I'm actually going to choose a heat map, and what I'm going to do is I'm going to use the color is going to be the actual raw voltage, the voltage level of the water sensor here. And of course, we're going to be using the main dimension as our timestamp. And for a secondary category, I'm going to be using water level. So if I click OK here, now the color is going to change depending on what that raw voltage level is, but you start to see that everything here is just dry, right? Now, if I take my probe and I start to make it a little bit damp, and we move it to yellow, now you start to see that the graph is reacting to that. And then when we go a little bit more, now we see that it's starting to break out into that level, and the color of the graph is changing correspondingly as well. So if I start to pull it back a little bit, there we go. Start to see that the graph is reacting in real time. And so that is just a quick example of using real-time streaming capabilities of the SAP real-time data platform, and a live example of what that looks like when we start to connect it out to external sensors. Thank you very much, and appreciate your time.